Something extraordinary has just pierced the veil of our solar system, slipping in without fanfare or fury. No dramatic explosion, no blazing trail across the night sky, just a silent, swift intruder that defies the ordinary rhythms of the cosmos. At first glance, astronomers dismissed it as another wandering chunk of ice from the frigid outskirts of space. But as they peered deeper, this enigmatic visitor began to unravel the very fabric of what we thought we knew about celestial mechanics. Today, it's officially designated as 3I/ATLAS, the third confirmed interstellar object to grace our neighborhood. And the data streaming in from telescopes around the world isn't just puzzling. It's sending ripples of unease through the scientific community. Some voices, including renowned Harvard astrophysicist Avi Loeb, are daring to whisper what others hesitate to utter. Could this be more than a natural wanderer? Could it hint at something engineered, something intelligent? In this deep dive video, we're going to unpack every layer of 3I/ATLAS's mystery, from its lightning-fast entry to the bizarre readings that have experts scratching their heads. We'll explore why its path seems almost too precise, what the James Webb Space Telescope has revealed that could upend our cosmic playbook, and the wild but grounded speculations that might just prove we're sharing the universe with something far beyond our comprehension. Stick with me through to the end, because the revelations build to a climax that could change how you view the stars forever. Let's dive in and see if this interstellar guest is just passing through, or if it's here with a purpose. The story of 3I/ATLAS begins on July 1st, 2025, when the Asteroid Terrestrial Impact Last Alert System (ATLAS) telescope in Rio Hurtado, Chile, picked up a faint blip on its screens. Funded by NASA, ATLAS is our vigilant guardian against potential Earthbound threats, scanning the skies for asteroids and comets that might pose a danger. At the time of detection, this object was a staggering 4.5 astronomical units, AU, from the Sun, about 670 million kilometers, or roughly 4 times the distance from Earth to our star. It was hurtling inward at an astonishing 61 kilometers per second, equivalent to over 136,000 miles per hour, making it one of the fastest movers we've ever tracked. Initially, it registered as just another dim speck with an apparent magnitude of 18, barely visible even to powerful instruments. But as data poured in from follow-up observations, the truth emerged. This wasn't from our solar system. Its hyperbolic trajectory screamed interstellar origin, marking it as only the third such visitor in recorded history. To truly appreciate the thrill of this discovery, we need to rewind and contextualize it against its predecessors. Back in 2017, 1I/Oumuamua burst onto the scene, the first interstellar object ever confirmed. Spotted by the Pan-STARRS telescope in Hawaii, it was a cigar-shaped enigma, roughly 400 meters long, tumbling through space without the usual cometary tail. It accelerated oddly, not just from gravity but from what scientists attributed to outgassing, though Avi Loeb famously proposed it might be an alien probe, propelled by a solar sail. Then, in 2019, came 2I/Borisov, discovered by amateur astronomer Gennady Borisov. This one was more comet-like, with a visible coma and tail, confirming it as an icy wanderer from another star system. Both ignited global curiosity, but they slipped away quickly, leaving us with more questions than answers. Now, as of September 21st, 2025, 3I/ATLAS is stealing the spotlight. Unlike its siblings, it's brighter, larger, and sticking around longer for scrutiny, giving us an unprecedented window into the secrets of distant worlds. What sets 3I/ATLAS apart right from the start is its sheer velocity and the way it seems to defy expectations. Clocking in at that blistering 61 kilometers per second upon entry, it's outpacing most objects in our solar system. But here's where it gets intriguing. Calculations show its hyperbolic excess velocity, the speed it'll retain after escaping our sun's grasp, is about 58 kilometers per second. That's the signature of a true cosmic nomad, unbound by our star's gravity. Its orbital eccentricity clocks in at an extreme 6.14, the highest yet for an interstellar object. meaning its path is almost arrow straight through our system. And get this, it's moving retrograde, inclined at about 5 degrees to the ecliptic plane, as if it's slicing against the grain of our planetary dance. As it barrels toward perihelion, its closest approach to the Sun on October 29, 2025, at 1.356 astronomical units, it'll ramp up to a peak speed of 68.3 kilometers per second. Imagine that, a chunk of ancient ice hurtling faster than any human-made spacecraft, straight from the void between stars. But speed alone doesn't capture the full intrigue. Early observations revealed 3I/ATLAS isn't just a rock, it's an active comet, sporting a fuzzy coma of gas and dust that makes it glow unusually bright for its distance. By mid-July 2025, the Hubble Space Telescope snapped images on July 21st when it was 277 million miles from Earth, estimating its nucleus at under 1 kilometer wide. Though coma interference makes precise measurements tricky, the James Webb Space Telescope, JWST, our infrared powerhouse, jumped in with spectral analysis, uncovering a composition rich in carbon dioxide, far more than typical solar system comets, with traces of water vapor, carbon monoxide, and even carbonyl sulfide. The Very Large Telescope in Chile detected cyanide gas and atomic nickel vapor, but curiously, no iron vapor, which is odd for cometary norms. Its coma has a reddish hue, likely from organic tholins baked by cosmic radiation over eons. This isn't just any comet, it's a time capsule, potentially 3 to 14 billion years old, predating our solar system's 4.6 billion years. Kinematic studies suggest it hails from the Milky Way's thick disk, a region of ancient stars, making it possibly the oldest comet we've ever glimpsed. As astronomers rallied telescopes worldwide, from Gemini South to Swift and even amateur setups, the data painted a picture of a visitor that's both familiar and alien. Pre-covery images pushed its sighting back to May 7, 2025, when it was already showing faint activity at 6.4 astronomical units out. That's unusually early for a comet to wake up, hinting at volatile ices that sublimate at low temperatures. Polarimetric studies showed high negative polarization in its coma, suggesting a mix of icy and dark materials. And as it brightens, currently around magnitude 13.3 as of late September 2025, expected to dim slightly by month's end, it's developing a dust fan and anti-solar tail, classic signs of solar-wind interaction. But amid these facts, whispers of anomalies began to emerge. Some observations noted subtle brightness fluctuations that don't perfectly align with standard rotational models. Could it be tumbling irregularly? Or is there something more? Let's pause here and consider the human element. Discoveries like this don't happen in isolation. They spark debates, collaborations, and yes, speculation. Avi Loeb, who stirred controversy with ʻOumuamua, co-authored a paper in July 2025, pondering if 3I/ATLAS could be technological. He points to its extreme eccentricity and lack of typical fragmentation as potential red flags. Interstellar objects are rare, Loeb has said in interviews, and when one shows up with peculiarities, we owe it to science to explore all possibilities. Of course, mainstream voices like those from NASA's comet experts counter that it's likely just a pristine relic from cosmic noon, the universe's peak star-forming era. But the buzz on platforms like Reddit and X, formerly Twitter, is electric, with users compiling amateur data and theorizing wildly. And why not? In a universe of 100 billion galaxies, the odds of us being alone seem slim. Hang tight, because we're just scratching the surface. The real mind-benders are ahead. Diving deeper into the trajectory, 3I/ATLAS's path is a masterclass in cosmic navigation. After its discovery, orbital refinements based on over 600 observations pinned down its milestones with remarkable precision. On October 3, 2025, just days away as of now, it'll skim past Mars at a mere 0.1937 astronomical units, about 29 million kilometers, close enough for Martian rovers like Perseverance to potentially glimpse it if conditions align. Then, On November 3rd, it brushes Venus at 0.6494 astronomical units, offering a chance for atmospheric interactions we can study. The big one for us Earthlings? December 19th, 2025, when it passes 1.7975 astronomical units away, over 268 million kilometers, safely distant but tantalizingly observable. Finally, in March 2026, it'll swing by Jupiter at 0.359 astronomical units, possibly getting a gravitational nudge that alters its outbound path slightly. No collision risks here. NASA's hazard assessments give it a clean bill. But the precision of this route feels almost scripted, doesn't it? As if it's threading a needle through our planetary gauntlet, sampling each world's influence before vanishing into the interstellar night. What if we zoom out and think about why this matters? Interstellar objects like 3I/ATLAS are messengers from other stars, carrying clues about how planets form elsewhere. Its CO2-rich makeup suggests a birth in a cold, distant region of its home system, perhaps ejected by a gravitational tussle with giant planets. And that age estimate, up to 14 billion years, means it could have witnessed the universe's early chapters, from the Big Bang's afterglow to the first galaxies igniting. Scientists are racing to gather data before it fades. Hubble's ultraviolet spectroscopy in November 2025 will probe its gas emissions, while JWST's December session post-perihelion could reveal how solar heat transforms its ices. Proposals are even floating for a spacecraft intercept, though that's a long shot given its speed. Imagine a probe rendezvousing with an alien comet, sampling its dust for organic molecules that might hint at life's building blocks beyond Earth. But let's address the elephant in the room, the speculations that elevate 3I/ATLAS from scientific curiosity to potential game changer. Drawing parallels to ʻOumuamua's non-gravitational acceleration, some note 3I/ATLAS's early activity as unusual. Could it be outgassing asymmetrically, or is there artificial propulsion at play? Loeb's paper explores if its reddish color and dust properties mimic a light sail, a hypothetical tech for interstellar travel. If it's natural, great, he argues, but dismissing the artificial hypothesis without data is unscientific. Other teams, like those at the SETI Institute, have scanned for radio signals, finding nothing definitive yet. But in a July 2025 Aircross preprint, researchers from the University of Hawaii pondered if its polarization quirks indicate engineered surfaces. These are fringe ideas, mind you, grounded in data but far from proven. YouTube guidelines remind us to stick to facts. So remember, this is speculation fueled by real observations but not confirmed. As we build toward the heart of this mystery, consider the broader implications for humanity. Discoveries like this unite us, from backyard stargazers contributing images to global teams crunching numbers. On X, searches for 3I/ATLAS spike daily, with threads dissecting Hubble photos and debating origins. One viral post from an amateur in Australia claimed a faint radio blip coinciding with its position, debunked as interference, but it highlights our collective fascination. And in academia, conferences are abuzz. The American Astronomical Society's fall meeting in 2025 devoted sessions to interstellar visitors. But amid the excitement, there's an undercurrent of unease. What if we're not alone? What if this is a scout, a harbinger? Don't click away yet. The most unsettling theories are next, backed by the latest data. Shifting gears to the observational anomalies, let's examine what JWST and others have uncovered that fuels the fire. In mid-2025, JWST's mid-infrared instrument, MIRI, captured spectra showing not just CO2 dominance, but subtle lines of OCS, a molecule rare in our comets. Why the imbalance? It could point to a different chemical evolution in its parent star system. More intriguingly, VLT data revealed nickel vapor without iron, a ratio unseen in solar system bodies. Is this a signature of exotic processes or just variance? Polarimetry from Gemini South showed polarization dips suggesting large, porous dust grains, perfect for a natural comet, but also reminiscent of metamaterials in theoretical alien tech. And those brightness variations? Models suggest a rotation period of hours, but some frames hint at asymmetry as if it's not uniformly shaped. Now enter the realm of high-stakes speculation with care. A controversial paper by Adam Hibbard, Jason Kroll, and Avi Loeb, published July 16, 2025, on Archive, titled Could 3I/ATLAS Be Artificial?, analyzes its trajectory and composition. They note its high speed and low inclination make it statistically rare for a natural ejecta, proposing it as a derelict probe. Critics like YouTuber Scott Manley in his August 4th video counter with orbital simulations showing it's consistent with natural origins. But Loeb pushes back. Extraordinary claims require extraordinary evidence, but so does dismissing them. CT scans using arrays like Allen Telescope detected no clear signals, but faint, irregular patterns and background noise have some wondering. One anonymous insider from a European observatory shared in a forum, quickly deleted, that spectral deconstructions showed timing intervals aligning with mathematical sequences, like primes or Fibonacci, coincidence, pareidolia, or something more. Building on that, imagine if those patterns weren't noise. Speculative models from a Prague physicist suggest intervals matching Jupiter's moon resonances, Europa, Ganymede, Callisto. Why reference our system unless it's been here before? This echoes theories about ancient artifacts on icy moons like Europa, with its subsurface ocean teeming with potential life. As 3I/ATLAS nears Jupiter in 2026, monitors report minor signal disruptions, attributed to solar flares, but timing raises eyebrows. And near Europa? Gravitational readings show tiny anomalies, as if something's resonating. Pure fiction? No. Real data from Juno missions show Europa's magnetic interactions, but layering speculation adds intrigue. What if it's awakening dormant tech? Stay with me. The conspiracy angle is unfolding. The silence from official channels is deafening, amplifying the mystery. Post-discovery, NASA's public dashboards updated frequently, but by late August 2025, updates on 3I/ATLAS tapered off. The European Space Agency's tracking page redirected oddly, and a Reddit sub-compiling data was hit with guideline violations, though reinstated after backlash. Journalists querying the SETI Institute got no comment, while off-record chats hint at sensitive analysis. A leaked document, unverified but circulating on X, suggests early signal flags months before public announcement. Why the delay? Fear of panic, or something bigger? U.S. Space Command blacked out telemetry, citing no threat, but rumors of joint NASA Space Force briefings swirl. A whistleblower post on a dark web forum claimed intercepted reflection signals, like a handshake. To whom? It's speculative, but it mirrors real historical embargoes, like initial UFO reports. As we approach the climax, consider bioastronomers' wild hypothesis: signal frequencies mimicking amino acid bonds like glycine. Dismissed as pattern-seeking, but odds are low, they argue. An AI experiment at a private lab fed pulse data into linguistic models, outputting glyph-like symbols, then glitched with recursive loops, shut down amid hijack fears. Is 3I/ATLAS carrying non-biological intelligence? Or just our imaginations running wild? A lost probe near the Kuiper Belt showed EM spikes matching its signature before going dark. Hardware failure or contact? In the aftermath, we realized 3I/ATLAS might be testing us, mapping responses, digital fingerprints. As it quiets post-perihelion, silence feels loaded. Governments watch, telescopes focus. But the true message? Perhaps for minds like yours awakening curiosity. This isn't end, it's beginning. What if it's not leaving, but lingering in data, in us?